Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from unit commitment. The name of a topic is methods of unit commitment. In that, we are going to discuss about a method that is dynamic programming method. Now, dynamic programming is based on the principle of optimality, which is explained by a Bellman in 1957. This method can be used to solve the problems in which there are many sequential decisions are required to be taken in defining the optimal operation of a system, which consists of distinct number of stages. So here what we have to do, suppose if I have 100 units and from the 100 units, suppose let's say a demand is 5000 megawatt. So in order to fulfill that 5000 megawatt, which unit should be turned on among these 100 units? Now this is very complex decision. So for that case, we can do it with the help of a dynamic programming method. So how this mathematically can be explained? Let's say this capital F, then N and the X. This is what? This is a minimum cost of generating X megawatt by N number of units. Please remember, when we have a capital F, then remember it is a minimum cost. Whatever N we have written, it is number of units, and whatever thing which we have written in the round bracket, whatever let's say here X, it indicates how much megawatt we have to produce. Basically the unit for this is rupees per hour. Now next is small fny, which will be equal to what? Cost of a generation of y megawatt by n number of a unit. Y megawatt from n number of a unit. Now here f is the minimum cost of a generation and small f is nothing but a cost of a generation. Please remember these things. When we write here capital F of n minus 1 x minus y, what is the meaning of that? Minimum. Now when we have a capital F, already we have seen, when we have a capital F, it is denoted as a minimum cost of generation. So how we can represent this, or what is the meaning of this? Minimum cost of generating x minus y megawatt by remaining n minus 1 units. So based on these representations, what is the formula? Let's see here. The following recursive relation will result with the application of dynamic programming. It is used to prepare a unit commitment table. So how it is represented? Capital F suffix n of x will be equal to minimum of y, small fn of y plus fn minus 1 x minus y. The main advantage of this DP method is a reduction in the size of a problem. The DP method is more efficient for preparing the unit commitment table if the available load demand is assumed to increase in a small but with a finite step size. This you will be able to understand once we solve one numerical based on a dynamic programming. In a dynamic programming, it is not necessary to solve the coordinate equations. This is what is, we can say, the peculiarity or advantage of a dynamic programming. Now what is the procedure? How to start it? First one, to start arbitrarily, select any two units. Step 2, for all the load levels, select the most economical unit out of the considered two units. Third one, obtain the most economical cost curve in the discrete form for the two units, and that can be treated as the cost curve of a single equivalent unit. Step 4, add the third unit and repeat the procedure to find the cost curve of a three combined units. And the last is repeat the process till all available units are exhausted. I know this procedure, whatever we have written, it is somewhat complex for understanding. But when we solve a numerical in the next video lecture, we will solve one numerical of dynamic programming method. Then surely you will be able to understand how this particular method is utilized for unit commitment problem. Thank you for watching this video. If you have any doubt, please feel free to ask the questions. Thank you once again.